All right, here we go. Day 2, two-step equations, okay? The other day we did talk, and I talked to you guys about you need to be able to start being able to look at these equations and have an idea about whether or not you're going to be performing one-step, two-step, possibly multi-steps, okay? So, again, just like we did the other day, this first screen here, all right? We're not going to solve these, but I want you to just start looking at them and just trying to tell if they're going to be one-step or two-step. So look at this first one here. X plus 4 equals 6. One-step or two-step?
Two-step.
One-step.
Two-step. Two-step.
Let me ask you this question. What is setting in front of the X?
One.
A positive 1. If there's a positive 1 setting in front of that X, you are really in good shape here. All we have to do is get rid of the 4 and you are solved. So that first one would be a one-step equation, okay? A lot of what's going to tell you a lot of the time whether or not you're dealing with one-step versus two-step or more steps is going to be what's setting in front of that X. If there is something there other than positive 1, then you are probably looking at more than likely a couple of steps, okay? There are exceptions, and I think we're going to see one here, okay? Take a look at the next one. 3 minus 2x equals 7. One or two step? Say it with conviction. Two step. That second one is a two-step equation. You're going to have to get rid of the 3, and then you're going to have to get rid of the negative 2, okay? So there are a couple of steps there, okay? Start trying to see that visual recognition of what you're going to deal with. How about the third one? 4 equals x over 3 minus 5. One or two step?
Two-step.
Two-step, right? Two-step. Got to get rid of the negative 5. Then you're going to have to get rid of a 3. How about that next one? X over 2 equals negative 6.
One step.
One step. What would that one step be? How would you get rid of the 2? Multiply. That's right. One step solved. Multiply by 2, done. Okay? There was nothing to add or subtract there. How about that last one? Negative 3x equals 6. One or two step? One step. What's the one step?
Dividing.
Division. Okay? Division. Okay? Guys, look at those. Look at those. We need to start being able to visually tell the difference between whether or not we're going to be using a step or we're going to be using probably more than one step. In a lot of cases, just 2. Okay? Any questions there on those? Start trying to see that visual recognition. Okay? All right. Okay. Little refresh from the other day. All right, here we go. Two-step equation. I draw my line. That line through the equal sign is going to break the equation into left side and right side. Right? That's what the equal sign does. What side is the variable on? Go. It's on the left side. Okay? What is the variable term? What is the term that has the variable involved with it? X over 4, okay? So that x over 4, that is the term that contains the variable. I'm going to refer to that as the variable term, okay? Your first job is to isolate that variable term. What else is on the left side with x over 4? Positive 2, okay? That is probably what you need to get rid of first. Guys, more times than not, you are probably going to add or subtract something first, okay? So how do we get rid of a positive 2? We subtract 2 from both sides. Positive 2 minus 2 goes away. You are left with x over 4 equals, and then what is 6 minus 2? 4. Isolate the variable term first. We got rid of a positive 2 by subtracting 2 from both sides. Here's what we have left. X over 4 equals 4. Everybody okay with that? Now, what's going on between the x and the 4? They're being divided. Therefore, we will need to multiply. Question.
All right. So when do you know when you're supposed to divide, when you're supposed to make the innate number next to x even, and then do you need to know when?
Quiet, please.
And when do you need to know when? And you have to make the number next to the number, and the number that you're adding, subtracting, multiplying, and dividing by and it equals. Like, for example, here we have to change positive 2 to negative 2.
Correct.
We have to change. Then we are left with x.
Right.
What situations do you have to?
Quiet, please.
How do I know what situations I need to do exchange with numbers?
Well, the whole idea, again, is that this variable term, the term that contains the variable, the x, right? You have got to get that term by itself, okay? On the left side of this equation, okay, not only do you have the x over 4, but there's also a plus 2, okay? So to get x over 4 by itself, that plus 2 must go away. How do we get rid of a plus 2?
Making it equal.
We subtract 2. We do the opposite operation. Add 2, we're going to subtract 2. 2 minus 2 disappears, and you are left with x over 4. There's that variable term that we wanted to get by itself. Okay?
My question was I get confused every now and then with which one I have to subtract or add by, like which side.
It's
different.
It's going to be the side where that variable is.
Oh.
That's the main thing that you need to recognize is where is that variable term? Where is that variable at? It's on the left side. Is x over 4 on the left side all by itself?
Yes.
Was it by itself?
No.
It was not. Okay? That plus 2 is over there with it. So that's what you're visually going to cue on first is where is that variable term? And I have to get that variable term by itself. Was there anything else over there with it? Yes, there was. There was a 2 over there with it. And we had to get rid of that, right? So in order to get rid of positive 2, we subtract 2. And that's what I did here. Subtract 2, subtract 2. Gone. X over 4 is by itself. 6 minus 2 is now 4. Okay? And IJ. Okay? So now that we've got x being divided by 4, how do we undo division? We multiply. So if x is being divided by 4, we want to multiply both sides by 4. And on the left side, these 4s are going to go away, which leaves us with x, and that's what we want. There's that positive 1x. And then what is 4 times 4 on the right side? 16. Okay? There is the 16. But it's all about working to get that variable by itself. Okay? Wherever that variable is, that's going to be the key to start with. Okay? So there's a little bit of a refresh over some of the, a two-step equation that we looked at the other day. Okay? Any questions before we go to the next slide?
You had to multiply on both sides. I thought you had to just divide on both sides.
Because the x is being divided by 4, we're going to have to undo that operation with multiplication. Okay? And guys, remember, with the equations, and I think you guys know this, the equation must be balanced. Whatever you do to one side must be done to the other. So if we multiply the left side by 4, we're going to multiply the right side by 4. Always balancing the equation. Okay? Okay. All right, take a look at these. Now, first thing I want you to do with these two, I want you to just visually observe the two equations, okay? The one on the right is one kind of like we just did. That was kind of what we saw the other day, okay? Do you see a little bit of a visual difference between the equation on the left and the equation on the right? Okay, I want you to notice something here. Over here on the right, what's the only thing on the top of this fraction?
X.
There's an X on top. Okay? Over here on the left, what's on the top of this fraction?
5 plus X.
5 plus X. Okay? So that is a little bit of a difference I want you to try to visually recognize is, one, both equations do contain a fraction. Okay? The one on the right, there's only an X up there. The one on the left, there's a 5 plus X up there. Okay? So, look at this one on the right here. Okay? I want to deal with this one first. What are you probably going to get rid of first in the equation on the right? Probably going to get rid of the 1, right? Here's your line. How do you get rid of the positive 1?
Right.
You subtract 1. 1's cancel. You are left with X over 2 is now equal to what? Positive or negative 3? 4 minus 1. Positive 3. Okay? Okay? And then how do you get rid of that 2? That is now X over 2, or X being divided by 2. How do you get rid of that 2? Multiply by 2. 2's cancel. 3 times 2. 6. Okay? All right? Pretty straightforward. That's one that we've kind of seen before. Okay? Any questions there on the right? Okay. This one on the left. Okay, now let me show you what's going to have to happen here. Okay? On the top of that fraction, and again, here's our line, left side, right side. Okay? On the top of that fraction, there are two things up there. There's a 5 plus X. There's a 5 and a positive X. There's an expression up there. Okay? Guys, what you're not going to be allowed to do here is you are not allowed to just subtract that 5. Because that's not really just 5. That's really, let me write this up here. Can you see that in red? The left side of that equation, technically, we're going to handle a little bit differently, but technically the left side of that equation is 5 over 6 plus X over 6. Both of those terms on the top are being divided by 6. So you are not allowed to just say, hey, I think I'll get rid of that 5 up there and I'll just subtract 5. That's not really just a 5. Okay? So here's what we're going to do. All right? And again, you have to recognize the look. This fraction has got more than one thing up on the top. So here's what we're going to do. Let me erase the red there real quick. Okay. So here's what we got. 5 plus X is being divided by 6. 5 plus X is being divided by 6, right? How do we undo
Okay, so how you would undo that is you add add 5 to x, and then you divide.
Well,
add 5x, which is 6.
we're not going to be able to touch that 5 yet.
Well, you would need to do, since it's dividing, the opposite would be multiplying.
That's right. So how do we undo division? We undo with division with multiplication. So watch this, guys. We are going to multiply both sides by 6. We are going to multiply both sides by 6. We are going to eliminate this denominator of 6. I'm going to get rid of this fraction. Because if I can get rid of this fraction, that 5 plus x now becomes a little more free to deal with. So we're going to, right out the chute here, we're going to multiply both sides by 6. Now watch this. Here's what happens. Those 6's on the left disappear. And you are left with 5 plus x. Okay? On the right side, what's negative 1 times 6? Negative 6.
Why do you have to divide 5 on both sides? Divide 5 on both sides.
Hold that thought. Okay, everybody take a look at what just happened now. Okay, the 5 plus x, that expression, that binomial up there, okay, is being divided by 6. You cannot touch that 5 and that x yet. We've got to get rid of that 6 in the denominator, so we're going to multiply both sides by 6. 6's go away. 5 plus x is left. Negative 1 times 6 on the right is negative 6. Now look what you've got here on the left. 5 plus x. What do we need to get rid of to get to get x by itself? And how would you get rid of the 5? Subtract 5. Watch this. Subtract 5. There's your x that we want. There's that positive 1x. I like that. Now here's one for you. What's negative 6 minus 5?
1.
It's negative 11. Oh, negative 11?
Negative 11, right? Same sign. Keep the sign, add the numbers. Okay? Same sign, keep the sign, add the numbers. Okay? So a little bit different look here, but one that we need to be able to recognize. Okay, and you're going to get a few of these today. We're going to get to dabble with this a little bit. Okay? But guys, if there's more than one thing on the top of that fraction, you're going to have to get rid of that denominator. Okay? And anytime we want to get rid of a denominator, we're going to use multiplication. Okay? We're going to undo division with multiplication. All right, take a look at that. Are there any questions there for now? Like I said, it takes a little bit of practice with these. Again, visual recognition, okay, of what you're dealing with. Okay? All right. Let's go to the next one. Here's my line. There's my left side, right side, determined by the equal sign. I think most of us are fairly conditioned that when you see parentheses, when we recognize parentheses, I think there's probably just a natural thought of potential multiplication here. Okay? Does this set of parentheses have a multiplier in front of it? What's going on between the 3 and that first set of parentheses? Is that 3 plus, 3 minus, 3 times, 3 divided by? It's times, isn't it?
It's 3 times x would be 3x.
Okay.
You would subtract 1.
Hold that thought. Okay. Everybody agrees this is 3 times, right? Yeah. Multiplication does not require a symbol sometimes. Okay. So, would we also agree that this is a distributive situation? Yes. We have 3 times x plus 1. that 3 is going to have to be multiplied to x, and it will also have to be multiplied to the 1. We need to distribute the 3. Christian, you are exactly right. 3 times x is indeed 3x. 3 times positive 1, though, will be positive 3. Make sure that we get that 3 distributed throughout the parentheses. Okay? And like I said, you guys will often see me draw lines there. I'm pretty visual. Okay? I want to see where I'm going with that 3. Is everybody okay with the left side? Okay. Now, once we have distribution done, guys, we are right back to equation solving. Okay? What is the variable term? 3x. 3x is the variable term. There it is. Is 3x all by itself on the left side? What else is over there with it? Positive 3. What do you think we probably need to get rid of first? The positive 3. And how will we do that? Perfect. Let's subtract 3 from both sides. And we've talked about this. A lot of the time you're going to add or subtract something first before you multiply or divide. Okay? 3's go away. 3x equals, guys, what's 9 minus 3? 6. 3x equals 6. How do we get the 3 to disappear from the x? Divide both sides by 3. 3 divided by 3, gone. There is your positive 1x. And 6 divided by 3, you are correct, is a positive 2. Positive 2. X equals 2. We always like it when it works out nice and neat, but you know, if we get something that's fractional, that's okay. I think we talked about that. Okay, it's okay to create a fraction, but we also like it when the answers work out to be nice integer numbers. Okay? All right, take a look-see there. We got any questions there? Parentheses are oftentimes going to indicate some possible distribution, so make sure we check for that. Get the distribution done, and then from there we're performing equation operations. We'll generally add or subtract something first, then come back and multiply or divide to solve. All right, let's do one more here. Jot that one down. There's my line. Do we have distribution here? Yes or no? Do we have distribution here?
Yeah.
Is this a distributive situation?
Yeah.
Yes. What is the number that's going to be distributed? Negative 2. Everybody see that? That negative 2 is going to need to be distributed inside those parentheses. Negative 2 times x. Negative 2x. Negative 2, what kind of a 4 is that? Okay, negative 2 times negative 4. Positive or negative? Positive 8. Remember, a minus sign and a negative sign are kind of one and the same, okay? So we're going to treat that 4 like a negative 4 when we're multiplying here. Everybody okay with the distribution? Everybody good with where all those numbers are coming from? What's the variable term? What's the variable term? Negative 2x. Good. Guys, Try to recognize where your variable term is. That's the first thing we're going to try to get by itself is that variable term. What needs to go away to get the negative 2x by itself? Go, Tiger. The positive 8 needs to go away. How is it going to go away? Thank you. Boom. 8 minus 8, gone. Here we go. It's a tough one here. Negative 22 minus 8. Thank you. You guys made it sound easy. Negative 22 minus 8, negative 30. Last step to solve. Divide by? Divide by what? Thank you. Divide both sides by negative 2. Negative 2 divided by negative 2, gone. Positive 1x. A negative divided by a negative is a positive. And what is 30 divided by 2? Is it 15 over 1 or 1 over 15?
1 over 15.
If we divide both these by negative 2, negative 30 divided by negative 2 is 15. Negative 2 divided by negative 2 is positive 1. Should just be a positive 15. Okay? Make sure you're dividing by 2. Make sure, some of you guys with these calculators, be real careful about how you're inputting that data on that calculator. Okay? Should just get a positive 15 here, which is nice. Again, this type of problem here is what I would consider fairly routine with some practice, okay? This is going to be one of those problems where, need to be able to complete the routine play. Question?
Can I use the bathroom?
Yes, sir. Okay, questions? Any questions? Okay. All right, so here's what we're going to add. We're going to add 6 through 8. $12. 17, 22, 24. 6, 7, 8, 12, 17, 22, 24. That should be picking up the problems that we did not do the other day that should look similar to the examples that we saw today. Okay? So you're going to see those looks. All right? So really, what is that? It's 3, 4, 5, 6. That's 7 equations. Heck of a deal, right? Heck of a deal. All right? So 6 through 8, number 12, 17, 22, 24. You're going to do those on a separate sheet of paper. Okay? It's going to be the same worksheet that we saw the other day. I reloaded it in there. Okay? When he gets back. Okay? The other thing that I want you to do today, okay? There's one more thing loaded in there. I want you to do this first, okay? But probably as we get closer to about 9:45, 10 o'clock, I've got a reflection in there, okay? And what you're going to do in there is you're basically just going to take a brain dump, okay? I want you to go in there, and it doesn't have to necessarily be in complete sentences, but I want you to try to remember anything and everything about one-step or two-step equations that you can remember, okay? Just start typing it out. It doesn't have to be complete sentences, but I want you to try to recall anything that you remember about solving one-step or two-step equations and just throw that in there, okay? So it's a little bit of a self-reflection, but I want to kind of see what you're remembering and just dump it in there, okay? Let it go, all right?